Okay, good morning everyone. I hope you can hear me and see me. Welcome to this live stream. My name's Stuart Sidders. I'm the Exam Solutions guy, and I've got my partner here, Michael, who's going to answer your questions that you might type in. He'll do as best as you can. I'm assuming that you saw my previous live stream, which was on integration one, where I introduced you to integration. And in this one, I'm going to take it further. We're going to now start to work with definite integration, and I'll be showing you how we can apply it to problems. We'll be doing some solving definite integration equations, and also I'll introduce you to a simple law that some of us use. And during this live stream, it should take about 30 minutes, say. I'll encourage you to answer some questions, so do have a pen and calculator at hand so that you can take part. You'll also find, just in case you do leave, there are some links in the description below to some further questions that extend what we've done. There's some video tutorials there, so do take a look at those for further exercises. Okay, so let us crack on, and I'll just take away in picture and we will be starting then. Okay, so I hope you can see that. Now then, we've got in the past, we've just seen in the previous integration 1 live stream, I introduced you to just integrating, this was this symbol here, some function of x with respect to x. And we ended up with our answer f of x. Okay, we looked at examples that had the form ax to the power n. So do check that out, as I say, if you're unsure of this. But what I want to be looking at now, though, is what happens if we put what we call limits on the integral. These are generally numbers. I'm going to put them as a and b here. And when you have these numbers here, we call this definite integration. And what we do is we take our answer that we had before and we put this in square brackets, something like this, okay, with our limits at the bottom here. A at the bottom there, and we have B at the top there. And what does this all mean? Okay, well, when we work this out, we substitute B first of all in for x, work out f of B, and then we substitute A into here and work that out and subtract our answers. So you get this result. Now, I'm going to show you that this is going to be used to work out several applications. One of them is area, for instance. Area bounded by a curve down to the x-axis between two lines, two vertical lines, let's say with equations x equals 1, x equals 4. We can use definite integration as one application to get areas like this. And what we'll be doing is working out the integral from what we call these limits from x equals 1 to x equals 4 of this curve here. We would integrate it with respect to x and it would give us this area. And we'll cover this example later on in this live stream. Another application, I'm not going to cover it here in this live stream, it's a bit further on, but we can take this shaded area here and rotate it about the x-axis 360 degrees, and what it would do would generate a solid. We call it a volume of revolution, and we can use definite integration to work out volumes like this. The formula for working out a volume of revolution is that it equals pi times the integral, and if it was this question that we were working with, it would be between the limits x equals 1, x equals 4, as given here. And we would square our function f of x and then go on to integrate it. Anyway, I'm just saying this without any proof at the moment, but I will be doing later on this example. Anyway, let's just move on and get to work out something like this. Now, suppose we had to integrate 4x cubed with respect to x. Then, in the usual way, if we were to integrate this type, remember, we add 1 to the power and divide by the new power. So we're going to get 4x to the power 4 over 4, and don't forget that constant of integration, plus c. Now, if we had a situation where we had limits, let's say we put a 1 here and a 3 here, we say that we're integrating this 4x cubed with respect to x between 1 and 3. We never say it, and I often see this as a mistake, that we're integrating between 3 and 1. Okay, we're not. We're integrating between 1 and 3. You always say this one first of all. Okay. Now, according to our rule up here, what we do is we write this in brackets, like so, square brackets, this kind of shape, and we put our limits on the end. Okay, 1 there, 3 there. Now, I'm going to show you something about the constant c in this. I'm sure there's a lot of you watching that might already know some of this stuff, and you might be asking, why on earth have I written a c there? Well, I'll show you what happens anyway with this c as we work our way through. Because what we do next is, well, I'm going to cancel this, okay? We'll just clean that up. The 4's cancel. We end up with x to the power 4 plus c between 1 and 3. So we start by substituting x equals 3 in here. And if you do that, you're going to get this result, 3 to the power 4 plus c. And then from here, we subtract what we get when we put the 1 through. And if you put the 1 through, you're going to get this result, 1 to the power 4 plus that constant c again. And if we now evaluate each of our terms, 3 to the power 4 is 81, we've got plus c, and then I've expanded this bracket, we end up with minus 1 minus c. And can you see that the c's cancel? We're just left with 81 minus 1, and that gives us 80. So, what happens in definite integration is that always these constants will cancel one another out. So we tend to not bother with putting the plus c in because of that. Okay, so you don't need to do that. Now I've got a question for you to try. Okay, so if you've got pen and paper, I doubt whether you'll need a calculator for this one, but I'm going to give you a question to do. Have a go at it. Shouldn't take you long, and we'll just see who's the first one to give me the answer. Okay, I will give you the solution to this shortly though, but integrate x squared minus 3 between x equals minus 1 and 2. Okay, so away you go. So while you're doing this, okay, I'll just say to you, say hi to a few of you that have joined me. I can see that quite a lot of you have. And thank you, by the way, to Michael, who is helping me from Air Maths Tuition to answer some of your questions along the way. Okay, so thank you, Michael, for helping out. Okay, so hopefully you're getting on with this one and managing quite well. Right, nobody's able to give me an answer just yet. So yeah, so good. It looks like we might have someone coming to answer this very shortly. That's good, Rebel. Rebel got -6. Well done, Rebel. First one out there to get the answer. Okay, so let's just see then how we do this. Right, okay, so we set up the integral. Remember, we are integrating between -1 and 2, so the -1 goes at the bottom here. We've got a couple of terms here. Remember, make sure they're in a bracket, okay? So we're integrating x squared minus 3 with respect to x. If you do that, you integrate it, you should get x cubed over 3, where we add 1 to the power and divide by the new power, and we'll end up with -3x. There's our limits, -1, 2. Substitute your values in, and you should get this result here, okay? Substitute the 2 first, 2 cubed over 3 minus 3 times 2, and then subtract what you get when you subtract the -1 in. Clean this up, what do you get? Okay, if you evaluate the terms, you should have 8/3 minus 6 plus 1/3 minus 3, and that turns out to be -6. Okay, so I can see then that quite a few of you have been able to get that -6. Well done. Okay, so you can see that I haven't included, by the way, the plus c. If I had have done, it would have cancelled out. We'd have had a plus c in this one and a plus c in this square bracket, and we'd have ended up with c minus c, still giving us anyway that -6. Okay. Right, well, what I'd like to do next is just take this a bit further. One of the things that you can get are equations. You'll see I've got one of these, for instance, as I say, in the description below this video. There's a link to a question, goes to my website and to that video tutorial. You're going to get questions where you're asked to solve a definite integral, okay, equation. In this one, we've got to find out this value of a. You're quite welcome to have a go at this, but I'm going to just run through this straight away, okay? And you'll get a chance to have a go at another one in a few moments. What we do is, well, we can copy this question down if you like. We'll copy it down, and it's an equation, so don't forget the layout is quite important here. What we do is we integrate our x minus 5 in the usual way, and if you do that, we're therefore going to get x squared over 2 minus 5x between 0 and a, and it's going to equal -12. So all I need to do now is just substitute my value of a into here and subtract what I get when I substitute the 0 through. And if I do that, okay, this is what you should end up with. A squared over 2 minus 5a, and if you put the 0 through, you just see I've just written -0. I could have obviously left that blank, but it's just to show you that I did substitute 0 in there. Okay, I can see that we've got a quadratic equation now, and we need to get rid of this 2 here, and I'm going to multiply through each of these terms by 2. That will give me a -24 on the end, and I'll add then 24 to both sides. So rearranging this, you should get this quadratic equation, which factorizes. Obviously you could use the quadratic formula if you wanted to, but it does factorize. We end up with a minus 4 as one factor and a minus 6 as the other factor. So in a case like this, remember that each of these factors could equal 0, and if you put them equal to 0, you'll end up with a equaling 4 or a equaling 6. Okay, and so that's a very simple equation involving definite integration. Now, I hope you're ready for this one, because I've got another question for you to do, and here it is. You've got to solve this definite integral equation. It's the integral of 3x squared minus 4 with respect to x, with it going from x equals a to x equals 2a. And this definite integral equals 59a. A doesn't equal 0, by the way. So just give me the value or values of a, whatever you come up with. And I'll just wait here and see who's the first to give us that answer. Okay, so it might take a little while, not too long I hope, but just a little while for anyone to give us that one. So, okay, so hope you're able to get this. I noticed someone, by the way, has written up that they're struggling with area between curve and lines. And in my next live stream, which is going to be coming next week, I'm going to be doing a series of live streams next week. I'm going to be extending this work. We will be looking at area between curves and lines, okay? We'll also be looking at areas below curves and other types of problems. And I'm going to gradually be building up the integration, just in case you're thinking where this is all going. I'm going to be building up the integration over next week. We'll be looking later at trigonometric integration, exponential, logarithmic integration, and so on. Okay, the area problem, I see someone's coming up with when am I going to be doing the area one. It's going to be coming up just towards the end. I've got a couple of sections to work through and we'll be looking at that. Okay, I see that someone's given me an answer for the values of a equaling 3.18 and minus 3.18. Jasmine, unfortunately you're wrong, okay. I'm sure you had a good go though, well done for trying. Rebel, again, well done. She's got, they've got 3 or minus 3 for A. Well done. Plus or minus 3. You're definitely a star here, I can see. Eleanor coming in with plus or minus 3 as well. We got one here, cube root of 27, which, yes, it would be plus or minus, well, no, cube root of 27 wouldn't be minus 3. It would just be 3. Anyway, the right answer is A equals plus or minus 3. And I will just take you through this, okay? If we integrate this then, you should have got 3x cubed over 3 minus 4x between A and 2a, and it equals 59a. What we can do now is cancel those 3's, and that leaves us with x cubed minus 4x between a and 2a equals 59a. And then we're going to substitute our limits in, starting with 2a and then subtracting what we get with the a. And so that leads us to this result here. All of 2a cubed minus 4 lots of 2a minus what you get here, which is a cubed minus 4a. So 2a all cubed is 8a cubed. We're going to have minus 8a here. And then if I expand this bracket, it'll be minus a cubed plus 4a equals 59a. And that's what we have here. Group up similar terms and you should find you get 7a cubed minus 63a equals 0. And I can pull out a as a common factor. So if we pull out the a as a common factor, I'm left with 7a times all of a squared minus 9. And I can pull out the 7 obviously as well. Now, when you've got this factorised, normally a would be equal to 0 and a squared minus 9 would be equal to 0. But a can't equal 0 from up here. So it must be the a squared minus 9 that equals 0. So if a squared minus 9 equals 0, then the square root of 9 is plus or minus 3. So well done, Rebel, and as I said earlier, for being the first to get that answer. Okay. Right, we've only got a few more bits to go now. What I'd like to show you now is another idea. It's an idea that some of us use, and it can be quite useful. And also, as we run through this, I want to also point out a few other very important things that occur. With this one, we've got this integral of 5/3 x to the power 4 integrated with respect to x, going from 1 to 3. And, well, I'll tell you what, why don't you have a go at this anyway, and then we'll review the answer, how you got the answer. This one shouldn't take you that long to do, so just give you a moment to have a go at this, okay? Wonder if Rebel will be the first to come up with the answer for this one. Or is there anybody out there that can beat Rebel? She seems to be the champion. Oh, here we go. Xnave. 242 over 3. Well done. You're the first. That was pretty quick. Okay. So, I'll just give you other guys a little bit longer if you want to have a go at this. Okay, yeah, Ali says the same. I'll take your word for it, Ali. Okay, so yeah, we've got a lot of people coming in now with 242 over 3. Well done. Okay, let's quickly go through this. Check how you work this out, by the way. This could be interesting because there's several points here that I'd just like to talk through with you. Okay, now the first thing is that I've pulled out that 5/3, the fraction 5/3. Now, you don't have to do that. I mentioned this idea in the previous stream. It's quite important if you, well, it's to your advantage, shall I say, when you're working with limits to try and spot that you can do this kind of thing, because it can often make the integral a lot easier to work with. You might want to just try this integral both ways, with the 5/3 inside, the 5/3 outside. You'll get the same result at the end of the day, but let's just see how this unfolds. What I need to do now is just integrate x to the power 4 in the usual way. So we know that's going to be add 1 to the power, divide by it. So it's x to the power 5 over 5. And I've kept that 5/3 out the front here. Now we've got our limits in, and all I need to do is just try and clean this up. And I can see at this stage that those 5s cancel. And that helps enormously, because what that means is I've only got x to the power 5 to work with when I substitute 3 in and then the 1 in. So if I simplify this by cancelling out those 5s, you can see that I've got 1/3 x to the power 5 between the limits 1 and 3. And so sub those values in, that's what I get now. I'm not working with fractions so much in here. So that's one of the advantages, okay? So if you work out 3 to the power 5 minus 1 to the power 5, and you're going to get 243, take away 1, that gives you 242 over 3. So well done then for those of you who are able to get that. Okay, it's another challenge in a way, okay? I've got the same integral again, I say the same, but this time I've swapped the limits round. I put the 3 here. We're going from 3 to 1 in this integral. Now, I wonder if you can tell me what you think the answer is, or you might want to work it out. So I'll just give you a few moments to think about that one, okay? Let's see if we get any response here on what the answer would be. Yep, Erica this time, straight in there with minus 243 over 3. Unfortunately, Erica, you are wrong. Yes, Jasmine just pipped you there, minus 242 over 3. I think that was a slight error, Erica, on your part. I'm sure you didn't mean that, but it's minus 242 over 3. What I'm going to show you is that just by swapping limits around, you end up with the negative of this result. And I won't delay this, I've got the solution here. You can see that I've done exactly the same as what we did here, all the way down through, only our limits are have been reversed. So what happens is we substitute the 1 in first of all, and we subtract the 3 to the power 5. And so what happens, instead of getting 243 take 1, we end up with 1 minus 243, giving us the negative result of what we had here, minus 242 over 3. And so what I want to draw your attention to then is this result, which can become quite useful at times, especially when we're working with, I can recall instances when I've been working out areas under graphs, quite advanced ones, that this kind of formula helps. You can see that what we've got here is that if you have to integrate f of x with respect to x between the two limits a and b, it's exactly the same as integrating f of x with respect to x. When you switch those limits round, just make sure you put a minus in the front. Okay? Now, just to prove that, you could prove it at some other later point, but I'm just going to quickly show you the proof here if any of you want to see it done. It's very easy. Just because of space, I've said let I equal this integral. And in the usual way, if we integrated f of x, we'll get some other function of x. I've called it capital F of x. And we'll be between those limits a and b. And we've seen that we would substitute b in first and then subtract what we get when we substitute a in. So f of b minus f of a. Now, if I pull a negative sign out the front of some square brackets here, swap this around, this is exactly the same as minus 1, if you like, times f of a, and minus 1 times minus f of b. It's going to give me this line up here. And you'll notice that this result in the square brackets is f of x going from b to a. Okay, but I've got that negative out there, and that is the same as this integral. The integral of f of x with respect to x going from b to a, only with that negative sign there. Okay, so a useful result. You don't have to use it, but it's just a technique which might save you a bit of time later on in some integrals. Okay, right, we're coming now to the end of this, and I'm just going to go back now to an application then of working with integrals. And one of those, as I mentioned at the start of this live stream, was that we can use it to work out areas under graphs. And I'm not proving this in this live stream, but just take it from me that if you had to work out an area like this, where you were given an equation of a curve, y equals f of x, and the curve was above the x-axis, and there were two lines, x equals a, x equals b, then the area bounded below the curve to the x-axis between these lines, which I've shaded blue here, is given by this formula here. Area equals the integral of f of x with respect to x between the limits a and b. And if we turn to this graph that we started with, f of x equals x squared minus 6x plus 10, then we could work out this shaded area by using this formula here. And if you've not guessed it already, that's your challenge. Okay, find the area then bounded by the curve y equals x squared minus 6x plus 10, the x-axis and the lines x equals 1 to x equals 4. Okay, and I'm sure some of you may well have started to do this by now, so we'll just wait to see who's going to be the first to give us the answer. And this will be the last bit of this live stream. So just give you a moment or two to try and work that through. Might take a couple of minutes, say 2-3 minutes. Always good practice, by the way, to try these challenges, because it will give you the sense of urgency, speed. So under exam situations, there's going to be a kind of tension there. So it's always good to be competitive here and try and get those answers out. I'm getting some answers coming in now, and Ex-Nave there's got 6. Maria, well done, Maria. You're always coming in with answers. That's 6. So good. So I'm sure you. I can see there is some competition out there. If I'm strict, to be honest, if I'm strict, both Ex-Nave and Maria, you haven't really quite given me the right answer. So anybody else want to chip in with the what I would call being very strict here, the exact answer? Remember I said find the area bounded by the curve, okay? So anyway, right, Ex-Nave, 6 units squared, well done, okay. Great stuff. Okay, I'm going to take you guys through this then, finally, just so you can check you're working. So the area then, according to the formula, is going to be equal to the integral of f of x. Remember, it could be called y in other questions, y equals x squared minus 6x plus 10. Okay, so we're integrating this with respect to x. Don't forget those brackets over 3 terms here. Between x equals 1, x equals 4. And if you integrate this the usual way, you're going to get this result here. I noticed the 6 and the 2 clean up, so worth cancelling that down to 3x squared. So if you do cancel that down, you're going to get that. Substitute in your limits, starting with 4, and then subtract what you get when you put the 1 through. And you'll see that if you evaluate those terms, you get this result, and tidying that up, it turns out to be 6. Now, I did say that I was strict in this because we are dealing with an area. Now, when it comes to exams, I must admit I don't often see this at all written, but I would like to encourage you to write square units or units squared, because we are working out an area here. Okay, so I would certainly encourage you to do that. And you can check this out, by the way, just by looking at this graph. Now, I know we've got square units and these look like rectangles. Okay, well, they're not look like rectangles, they are rectangles that I've got here. I haven't drawn this graph on equally spaced intervals, and that's why you're getting these rectangles. But nonetheless, can you just see that you've got, let's say at a glance, you can see you've got roughly 6 square units here. You've got 1 here, 2, 3 along the bottom. You've got another almost whole one there, that's 4. And put a few little bits together, you can get 5 and 6 square units there. So you can see that it looks good. Okay, so that really is it for today, and I hope you've got something from that. Do, as I say, look in the description. There are links to video tutorials on this so you can do similar questions, and they've got the answers there, so it should give you more practice. And I hope you'll join me next week. As I say, I'm going to be doing plenty more live streams. Do, by the way, also, if you've liked this tutorial, please press the like button. It just gives me an idea how many people are watching, liking, and so on. Okay, and if you feel like subscribing, that'd be also really good. Okay, so I'll leave you to enjoy the rest of the day, and hopefully see you next week. Okay. Thanks for watching. Bye for now.